All right. So last time we were you might want to hit the lights while you're back there if you want. You guys want to see it? Good. All right. So last time we were um starting to implement the homework over the weekend, getting to the point where we can talk about the performance slowdown and ways we can get around that, which will be your homework over the weekend. Let me hide this. Wait, let me make sure. Yeah, my microphone's working. Okay. All right. So right now I think I have the thing just falling out of the sky once and hitting it. Oh, we don't have the thing off center or anything right now. Because I have my starting guy. There's my drop point. So last time we made this drop point, which is a thing that's up kind of in the sky. And right now I have our bad guy, who's the red ball, kind of attached to that drop point. Um, he's going to be our initial, uh, uh, our initial thing that's going to drop. Or we can make him invisible and just let him be um, the starting point. Bottom line is we just have to have a way of saying this is the kind of object that we want to fall out of the sky. So I'm going to move him over just a little bit, just so he hits a little bit off center. We'll drop that. And then we're going to start raining down more of these. All right. And then what I'm going to do for the example is I'm going to have it rain down. I'm going to keep having it go up by 2, double the number that will be generated so we can get out of control pretty quickly. Um, Rather than I think I had you guys tune it with a number or something like that. All right, so let's get into the script for this dude. So we attached a script to drop point called Rain the Fury. And what we did is we had a public variable, public field in there called drop object. Let's update that later. So we had a public field in there called drop object, and drop object is attached to our bad guy. Sorry, drop point. Here's our bad guy here, which is the red ball. So he's the thing that we want to instantiate. All right. So let's just start by instantiating one of those at the location that is our drop point with a little bit of wiggle one way or another, kind of randomly. That's what we were doing. That way they wouldn't hit quite dead center. All right, so let's start with just randomizing the position of the current. Uh, you know what? We don't need to do that. We can just we'll go ahead and instantiate a new one. So let's get into our script. So our script looks like this. The script is attached to our empty game object. So this dot transform is the location of our invisible drop point that's currently holding the first bomb. All right, that's what's going on there. All right. Now this bad guy here does have a rigid body attached to it, which means he has gravity. Um, now, so he that's why he starts falling immediately. So when we create new instances of these guys, they'll start wherever we create them, but then they're going to immediately start falling because they have mass, they have gravity impacting them because they have a rigid body. So they're going to keep falling out of the sky as soon as we instantiate them. So we really want to get a new transform. So we're going to create a function that just generates transforms. It's going to say, okay, well, here's your starting transform. So now we're going to nudge X, Y, and Z just a teeny bit one way or another, maybe somewhere between uh, 0.1 and 0.5, maybe. Let's see how that goes. Hopefully it doesn't get too far off. Let's do 0.1 to, yeah, let's just do 0.5. We'll see if they miss. It's fine. All right, so we're going to go ahead and create a function. This guy will be private and it's going to return a transform. What kind of object is a transform? No. Transform, what are transforms? Transforms hold what? Three things? Go ahead. No. What does a transform hold? Position holds XYZ. Rotation holds XYZ. Scale holds XYZ. So a transform holds position, rotation, and scale. So what do we call something that holds three values? Vector3. So this guy is going to return a Vector3 because we don't actually want a whole new transform. We're not changing the rotation. We're not changing the scale. We want to replace the position element of our instantiated object with a slightly modified position. Sound good? All right. So this guy's going to return a Vector3. We're going to say generate drop position, something like that. Oh, you made it today. You just missed the quiz. Oh man, look at this. 2 zeros in a row.
Wait.
There was. Oh my gosh, just garbage. He was complaining about me throwing him under the bus in front of the investor group we're working with yesterday when I said, oh, he didn't show up to class. Now it's 2 days, the whole week. The whole week. But we'll have to embarrass you in person at the meeting tomorrow or Zoom, however they said it. Well, you should be. This is you get shamed into obedience.
So where's the quiz at? See it.
No, it was me taking attendance and giving 100 points of quiz points, just like the last one that you got.
Well, I'm here. So.
You weren't here when we gave the quiz. Class started 11 minutes ago.
Yeah,
It's a tough one. It is a tough world. Carson did. Carson was actually was he the last one? No, John came in. We gave him the 3 minutes of because he did the lights. he brought an offering. It was a burnt offering. He turned the lights off. All right. I didn't do a quiz today, but start showing up on time. Oh, did it? Now, see, that would have been a legitimate excuse because I know what it's like to deal with that. One time when I came back from Rome, that's how all stories start with rich people. One time I came back from Rome, the entire basement, the hot water heater had failed. I'm guessing about 10 days prior. So luckily we had carpet then. So the carpet absorbed a lot of the water, but we had maybe, I don't know, 4 inches of standing water across like an 1,100 square foot basement.
Oh my gosh.
But what worked, so they, insurance covered. No, just hot water. The insurance covered it all. I would say insurance didn't give us enough to get it back to where we previously had it, but gave us a fair amount based on getting a basement sort of kind of patched back up.
Ours flooded last year and we made $3,000 off.
Yeah, I get it. Yeah, sometimes it works out.
And I was like,
Yeah.
now I'm thinking about it. What else?
It kind of happened with my solar panels because I did my whole solar setup myself until I brought the electrician in to get it to code. So mine was like a $70,000 system that I did for under 30. So then we got hit by lightning the 2 days after it went active, and I probably came out 10 grand ahead, something like that.
Yeah. Okay.
Well, I had to spend it on replacement solar stuff.
Yeah.
I didn't just like pocket cash. I just upgraded my solar stuff. I went from the Chinese made $2,000 inverter to the top of the line Solarc 15K military hardened thing for, I don't know, like 16 grand or something like that. So I heavily upgraded. All right, do you have a question?
Yes.
We're jumping back into it. So we're transitioning. Okay.
So we're calling Vector3 because, have the three potential like arguments in a sense.
Well, I mean, this guy's job is we're going to call this function every single time we create a new instance of one of these guys, because we want to tell it where that instance is going to be. So we're going to start with the vector3 that is the transform of our drop point, but then we're going to replace the position with our random position that this is generating. So this is generating a position that's just a tiny bit off of the transform that we're currently looking at here. So we're going to start the function here. So I'll go ahead and show you. So we're going to say vector3, we're going to say cur pos, and this is going to be this dot. And I think I showed this before, but you could just say this dot transform. I like to say this dot game object dot transform dot position, like that, because it is the game objects transform that we're talking about here. So I like to say this dot game object rather than just this dot transform. So now I have just the position component of that guy's transform. So I want to update that. So I have my current pos, which is that guy. So now I want to update this dude. So I need to review real quick. I think I showed you how to get random numbers, didn't I? I think it was still random, maybe just next something, Unity random. It actually is going to be, oh, actually Unity does have their own random thing. You don't have to use, so where is it? Random dot range. Okay. Got it. Actually, hold on. Random dot range. This is gonna, so -10 to 10. All right. So we're going to go ahead and say random R. Do I have to instantiate it? It's a class. So we see this. It's a class name calling a function, although that function starting with a capital letter seems pretty sketch, because we've learned to use lowercase letters to start our functions and then do camel case, but that's fine. So random dot range. And this guy takes a beginning and ending position. So what we're going to do, I'll do this later. Brady, what's kicking? Still not good. All right. You got to set it. They don't go off when you don't set it. All right, so what we're going to do here is we're going to create a nudge. So we're going to generate a random number between 0. Did I say 0.5? Okay. So we're going to do 0.5, negative 0.5.
Well, actually, isn't it negative 5.0 since that's the
No, you do not want to do steps that large. If we do, yeah, I mean, if we start stepping that far over, you're going to be missing. Well, I'm going to take this small value and I'm going to add it to the current position. You actually might need to. It was going to yell at us. 0.5f, and we talked about that yesterday, right? Or last time, that doubles are the default. So when you type a floating point value into, frankly, any programming language anymore, it assumes that it's a double precision value, which is more decimal places. If you want it to be a float, which generally it will never be our decision. It's not that we want it to be a float. It's that whatever library we're using, which is probably based off an old C library, it takes in floats. So you have to say, yeah, this is actually a float, which then means you are limited to how big of a value you can put in there. Because remember when we talked about the difference between floats and doubles, a float is kind of like an int. A float is to a double as an int is to a long. So a double holds bigger values. So a larger value before the decimal point, as well as a larger value after the decimal point. So before the decimal point, a float is a A float is 32 bits before the decimal point, and it is 16 bits after the decimal point. So it's a 48-bit value. A double is 64 bits before the decimal point and 32 bits after the decimal point for 96 bits total. So it's a bigger value, but it also has more precision, maybe overkill precision in 99% of the stuff we might need to do, which is weird that it's our default, but whatever. So that's why we're having to give it floats. All right. So this guy's going to give me some value. Float, we'll call this guy the nudge. All right, so we have our float nudge. Now we already have our current position. So what we're going to do is we're going to now call our nudge multiple times. So we're going to say nudge on X, nudge on Y, nudge on Z. Then we'll go ahead and create a vector3. Call this nudge vector is equal to a new vector3, passing it nudge X, nudge Y, nudge Z. Now you could actually build
Vector3.
Oh, it's because it wants me to specify it comes from Unity Engine. Oh, I see. Thank you. But it's still complaining. Well, it's because Vector3 exists in two places. It exists in the system namespace as well as the Unity Engine namespace.
Could it be your ports?
No, it probably is. I have system numerics. What am I using that for? Oh, that's fine. All right. But that was a good error for us to see when you have two objects types in multiple namespaces or multiple modules that you're importing. You either have to specify, I mean the Unity Engine one of these. So you'd say Unity Engine dot vector3, because you have to specify which of the vector3s you're talking about. Or in our case here, presuming I was doing something else last time and that's why that thing got imported, just get rid of the ambiguous imports. All right, so I created a new vector3. Now we could have inside of this vector3 said nudge X plus curpos dot X or nudge Y dot curpos plus curpos. So we could have done curpos dot X like that plus curpos dot Y plus curpos dot Z. So we could have done that. How many times do I have to click later for it to stop complaining? All right. So I could have done something like this and made our new vector3 with the nudges taken into consideration, but we can also do vector math to make this work, which is probably the preferred way of doing it. So I'm gonna get rid of our pluses here. So now what we've effectively done is we've created a vector3 that is the representation of our nudge. We can think of it as like our little shove. It's shoving a little bit in multiple directions. All right. So now what we're going to do is we want to return curpos plus nudge vector. So curpos is a vector3. Nudge vector is how much we want that vector3 to change. So we're going to add those guys together and return the value. So now we have the modified vector3 that is the original vector3 with the nudge applied. All right. Now, this isn't necessarily better than what I had in there before. Because what I had there before, we would have just returned nudge vector instead of cur pos plus nudge vector. In fact, we probably could even say that this is a little bit slower because we're asking it to do some matrix math for us when we sort of kind of could have just added 3 values in and made the world better. But this lets us see the vector math stuff. This is one of those things that game engines will do for us. And it's helpful so you don't have to think through all those little tiny details. Just say, hey, I want to take this and I want to take this and I want them to add together. I want to multiply them. If you want to build up magnitude for something, you probably saw that with speed in the tutorial. Or maybe it wasn't speed. It was probably the force from the controls or something. You added vectors to it. You built up vectors on every time delta time. Probably kept pushing it differently. All right, so now we have this function that can do this for us. Now in start, do we need to do anything in this particular case to start? Everything's already staged for us. So, I mean, we could go ahead and have the first guy drop, but we saw what happened when we did that last time. If I make my first guy drop right here, well, actually, he will happen right here. What happens? I'm just going to start the program real quick here. When I run this, I think we see that this guy has already almost hit the ground. Oh no, we changed it last time. We were instantiating something inside of start. And when we instantiate something inside of start, it has already started its motion before we see anything. So it was like already on the ground and bouncing off by the time the screen even popped up. So you want to think about that. Start is kind of our place where we can set stuff up. Then updates where we want to do stuff that that should already be seen. All right. So probably in updates when we want to start raining stuff down. But we probably don't want to do it every single frame. Things get out of control real quick. So let's do that. Here, so we'll go into our update. So right now we have a function called generate drop position, and this is the guy that will give us the position of the thing we're about to instantiate. If we look at the documentation for instantiate, we have a whole bunch of different versions of instantiate, polymorphism, right? All right, it's a whole bunch of different versions of this. So we have, here's the original object. We can just instantiate it right where it used to be and just have it start raining down, not do anything weird with position. We can give it the transform of the parent, which is what we are going to, well, we're actually not going to do it there. We're going to instantiate the top thing and then change it. So we're just going to create this guy, bring him into existence. So we're going to use this top level one here. Notice that it is static. So we call it using the name of the class in which this guy's defined. Instantiate is inside of the object class. So we could say object.instantiate, or we could just say instantiate. All right. So inside of update, oh, we already started doing this. But I'm going to take the delta time out here right now. All right, so we'll instantiate this dot drop object every single frame in its current location. Now, first of all, it is giving us a location. It seems like it's instantiating at some sort of, yeah, because they all have gravity. So it's location of the first one. We are instantiating it at the location of the first one, and the first one's location keeps changing because he's got gravity. So he originally fell, started bouncing off, then kind of came under, and then he was down, down, down.
We're instantiating at the location of the wall, not the transfer.
That's it. So now let's get it up higher. So now we're going to say, we're gonna not instantiate it at its current place, but we're gonna say this dot transform. Broke my own rule. This dot game object dot transform. So now we're going to say we're going to instantiate it at the location of the guy who owns the script, which is not the game object itself, not our drop object. It's the drop point. Actually, that's interesting. How far out do we need to go? Was that world space? Let me try something here real quick. Well, let's just do it off of position. Oh, no, it wants the full transform. So that's the transform of the, do we need to do local transform?
Could we also do method that we just?
Well, we're going to, but that's only going to give us our top vector 3. But this thing should be instantiating at the position of that top level transform. Look at the documentation here real quick. Oh, maybe we need to do the world space. Let me just try this real quick, then I'll explain the difference. I'm gonna bring this guy down. I want to see what's going on here. Go ahead.
Well, I think we're already gonna add the Vector3 generate drop position,
Mm-hmm.
but if you do, there's also a coordinate identity.
Oh, that's rotation.
Yeah.
Yeah, so we don't, I mean, this is a sphere. We're not gonna be able to tell how it's rotated. Yeah, so yeah, quaternions, we're gonna get to those. That's how you handle rotations, and that's kind of an area where quaternion mathematics is pretty complicated math. Um, that's where this guy really starts helping us quite a bit for calculating those things and Euler angles and things like that. Vector math is helpful, but not, that's something that we can handle if we wanted to. It's just tedious. Quaternion math starts getting more complicated, more mathy, and you want to kind of let these things do it. I want to see what's happening with this this location. All right, so what I'm going to do here is I'm going to put a 3D cube off this guy. So drop points right there. Here's my cube. I'll just bring it down near it. I want to see what happens with this cube. Okay, so he's not changing. All right. I think it's because I don't think anything's wrong. I think it's because we are currently inside of update and it's happening every frame and it's still trying to catch up. See all those things initiated at first, and this is the slowdown. So I don't know if we would have seen more or if we overwrote it, but let's give us some delay so we can kind of just see it trickling down with a time delta time greater than a second. So let's go ahead and open up the documentation for unity time dot delta time. All right, so well, this is what you saw inside of your tutorial where you were making those guys rotate. You know, so what you did is you had them happen over time. So it was little tiny nudges each time. So every single time we call time.delta time, it's the amount of time that has passed since the last time you called this. All right. So that means that if we want to do this over a period of time, we have to have a variable that builds up delays until we get to, like, if we want it to drop every second, let's say, we have to build it up to, it's probably 1,000 because I think we're getting milliseconds. So let's get it up to 1,000. So I'll go into our script here. I'm going to give myself oh, there's my timer. So inside here, we're going to say timer plus equals time.delta time. Then we're going to say if timer is greater than or equal to 1,000, it's only one. So it's a fraction that leads up to one. Okay. So, but if we get to that, then we need to say timer is equal to 0.0. Because we want to reset it and have it move to the next 1 second timer. All right, hold on. We are seeing it instantiating off of the parent transform still, which is the original. Well, it was still creating them. The first one had just fallen off the screen. So it was still creating them. So I think what I'm actually going to do then, this game object transform, it's off the top level. Why would that change?
I think it's because it's trying to attach to enemy.
Well, but this game object is the guy who owns this, which is our empty game object. And his transform is his location. So just to confirm, drop point is the guy that has Rain the Fury attached to it. We do not have him attached to our bad guy, do we? We do not. So this guy has that transform where his location is, but that location is not changing. So then the question is why is this guy, who we're saying instantiate this drop object at this location? I think this guy didn't make any difference, so we won't really talk about him. So I want to do it. Is it relative to that location? Which one is that? This one? Nope. This one? Yep. So that quaternion identity thing here says rotation of 0. So whenever if you did linear algebra, whenever you have identity matrices, it's the matrices filled with 0. It's kind of like saying you're multiplying something by 1. So it becomes itself. All right, so let's see. Why is this guy? Oh. I think I forgot something here. Let me test something real quick. Do I already have a prefabs? I'm going to create a folder here called prefab. You remember prefabs from your tutorial? What are those guys? Get rid of this guy. All right, so a prefab is kind of like a blueprint. So we created something in our scene or whatever, got it looking the way we wanted it to look, dropped it down into our, just into our assets somewhere. We put it inside of a folder called prefab. This now is a blueprint for things that we want to create. So then I took the guy out of here. We saw that it was working from within here, but I think his transform was becoming a problem. Let's see if this is the case. All right, so I actually filled this spot here for drop object from the prefab. It's not something that's already instantiated. So let's yeah. All right, so we're looking better with that. Um, give me until Tuesday to give you a better explanation on what was happening with the other thing, because I still feel like it should have been relative to our drop point, my empty game object that I have the cube hanging off of right now, so it looks pretty. So I can see it. You're,
What's the way that I put mine to Vector3, excuse me, the method that we just made, and then set the coordinate on identity to 0, and it works just fine.
well, no, it would, because that's going on. That's a relative of 0, 0, 0. Oh, so maybe that does answer the question. So it was instantiating it at, no, I don't think it does answer the question.
We're calling something, but it wasn't.
Well, no, where my misunderstanding is when I instantiate something at a location and it's a location that I do not expect to be changing, why is the instantiation point changing? It seemed to be relative to the original guy who was a child of drop point. I wonder if that had something to do with it, that it was a child of drop point, but I don't know. Let me look into that some. But in any case, we have it dropping better for us now. So let me move this dude up.
Wait, aren't you essentially instantiating drop point and instantiated that ball falls down? You're calling the location of drop ball again?
Yeah, see, it actually is still. So if you see what I just did, I moved this guy back up, but it is the transform of this dude that it's still using. So if we watch this go, I've moved my drop point way up in the air. So I'm expecting it to spawn off of this place right here. It is spawning off that place. What? Oh, I moved the cube previously? Oh, okay. Thank you. All right. Well, whatever. It's doing what we wanted to do right now. Well, yeah, previously I guess I had drugged the cube up, but now I made the cube invisible. So my invisible game object drop point is now just up here off the screen. And it is his, if I go here, it is that guy's transform that we are instantiating this prefab from. So that's where he's showing up every single time. All right, so now let's drop this down to maybe 0.25. Get it dropping a little bit quicker, make sure we're seeing it do its thing there. Then we'll start increasing the number of things that are dropping. And we'll start changing our location. All right, so that's doing its thing. So now what we're going to do is we are going to say, I'm actually, I'm not going to return this exact thing because we'll have to do the math somewhere else. This is our new position vector. So this is our Vector3 new pos is what that guy actually is. So what I'm going to do then is I'm going to say curpos dot pause position. No, curpos is my position. So curpos plus nudge vector is my new pos. There we go. All right, so we're going to say this dot game object dot transform dot position plus equals new pos, and then we'll return this dot game object dot transform. We'll give them the whole transform. So I think this guy is actually considered a transform rather than a vector3. So we'll call him a transform, even though transforms are implemented in terms of vector3s. So this is going to return the entire transform whose position has been modified slightly by our new pause, which was the original pause. Actually, I'm just going to say that, not plus equals. Otherwise, I would have been adding twice. I already added in the nudge. We don't need to re-add the nudge. So here is my new position with the nudge applied. So I'm going to replace transform's position with that new position and then return the entire transform. And then what I'm going to do here is instead of saying game transform like this, I'm going to say this dot, what did I call it? Generate drop position. And that guy's going to give us a brand new transform that has a position that's slightly nudged one way or another. So let's see what this looks like. Hopefully it doesn't look quite as uniform, yet it still hits. They're bumping into each other up there. So it is changing. At least we got that. All right, so let's give a little more time between the drops.
Once the ball change position.
Because they're hitting each other.
Well, but if you play that again, right, ball drops. Let's say 0-0, the transform position changes, but why would the already dropped ball change position? See that? There's the other one.
Because the other ones are hitting it.
No, look at the other ones over there to the right. It's not being hit. This is the jump. It's just jumping on its own.
Oh. I see what you mean.
Like, it makes sense that they would.
No. I get what you're saying. No, because they're saying it's already on the ground. Why is it still bouncing?
Yeah, keep dropping straight.
Because, well, okay. I mean, I have some theories here.
I think it's the Unity Pro. You know what?
No. Okay, well, I'm going to tell you what's happening. So remember, think of these like marbles. So they are physically falling out of the sky. And when they hit that thing, yes, they're bouncing off to the side, but they still have energy. Now they're hitting the ground. So these guys are bouncing along the ground I'm pretty sure that's what's happening. This is still kinetic forces working on it because it fell out of the sky. It was bumping into stuff in the sky. We kind of saw that happening. And now, what has happened now?
I don't think so. I think it's like the red balls are locked into. Okay, I'm gonna not explain this well, but the red balls are like locked into one reality, and then there's the blue and green in a separate, and the entire like reality of the red balls keeps shifting.
Okay, well, so that would mean that we could use something called local position. Let me go to the code here.
Could be seen as like a frame.
Well, I mean, I feel like it's relative to our drop position. Well, let's think about what our drop position is getting. Our drop position is getting the current game objects transform, but is that guy's position changing? I don't think so, but we can look at it. So I'm going to click that guy while it's running. So let's watch our drop point. Yeah. So my drop point's position is shifting. But it's an empty game object. Why is that shifting?
Can it be because you're calling this dot instead of just the method, which returns just the position value?
But I'm not changing this guy's. Oh, I am changing it. I am changing it. Give me a moment. All right, so that's my Vector3. That's my new Vector3. Oh, and aren't I just returning the transform each time? I'm not even returning the nudge anymore.
It's just the position.
So what I'm going to do is I'm going to make a transform t is equal to a new transform, and this guy's going to have new pause as the position, and then this dot game object dot transform dot rotation. No, yeah. And then this dot game object dot transform dot scale. We have just normal scale. We have to use local scale. All right, so transform does not contain a constructor. So let's go and look at unity transform. Can we not create a transform directly? Yeah, this shouldn't be the problem. We don't have to create a J transform. All right, so we're gonna do this. This dot game object dot transform dot position is equal to new pause. And then we're returning the transform. That's which has now been updated from the guy here. Okay, let's look at this first, but I don't think this explains why our starting point is moving. So we want to keep an eye on this drop point and find out why he is shifting. But why? But why? So we're modifying his transform. All right, we're going to do this. We are not going to make the change here. This guy is still going to return a vector3. This guy is just going to return new pause. I think this will answer the question. So this guy gives us a vector3. We want to first instantiate this at this dot game object dot transform. So we're not going to make any changes to that. Do we get, let me see here if instantiate returns the instance. I believe it does, but let's just make sure. Am I on? No, it's random range. Is this instantiate? Yes, instantiate. Does instantiate return? He does return the object that was instantiated. Okay. So we're going to say game object new object is equal to that. Then we're going to update that guy's transform. So we're going to say new object dot transform dot position plus equals this dot generate drop position. So we'll instantiate it, then we'll nudge it. And we're not changing anything with our original guy's location. So we're only changing the position of the thing that was recreated, or the newly created object. Let's see if this guy looks a little bit better now. Okay. So we can agree that looked correct now for what we're doing now. So now, can somebody explain to me what this just told us? It's kind of a hard question, but this did explain something to us that it involves the class transform. When we saw it operating the, let's say worst, was when we were returning the transform. A transform is a pointer to a thing. So we were making changes to a transform, expecting that we were just returning this new updated location-y, rotation-y thing, yet it was still attached to the original object. So we were moving our original game object around by making modifications to his transform. And he didn't move too far off initially because he might have been moving kind of back and forth and stuff because we were making changes to the X and Y, but then we saw we got bad luck and it started floating off to the negative Y. No, Y is this way. Z, I guess it would be Z. Whatever it is, it's one of those. I think it's negative though. I think it's a reverse axis. Good.
So you were saying that we were basically trying to drop our object from the original game object instead of the drop point.
Yeah, no. If I'm the drop point, I have my location here and I have a transform. So me.transform has a location. What I was doing is I was making modifications to my transform and then returning my transform for the new spawn point for the red ball, which was fine. But the red ball was spawning at different places because it was always spawning wherever I was. And the thing I was changing was my location. So I'm meandering along the map, spawning red balls wherever I am because we were changing my transform. Now what we're doing is we're back to what we were doing originally, where I said, okay, look, I'm going to take our original transform, but I'm going to take his position, which is the Vector3, which is like a struct. If you remember back to coding 1, when we talked about structs versus dictionaries, we mentioned that dictionaries, for instance, in Python, are passed by value. Remember the conversation about passed by value versus passed by reference? So passed by value means we're giving a copy. Passed by reference means we're giving a pointer where you can find it. In a language like C and C++, well, especially C is where structs are most commonly used, we had these things called structs, which felt a lot like dictionaries, but they had a behavioral difference in that a struct is passed by value. When we pass structs, which are a bunch of name value pairs stuck inside of a single primitive, it gets passed in the same way like an int gets passed. So when I'm passing a Vector3, it's like I'm passing an int. Okay, here is data that you could do whatever you want to. It's not going to mess up me. Yet when we were returning the transform and we were making a modification to the original transform, that was that example of you going to my house and spray painting my garage. I was actually shoving the original guy around, and he was always spawning the red balls wherever he was. They were moving, sure enough, but the spawn point was moving too. So now we're returning something that gets returned by value, Vector3s. And then we're using that Vector3 to set the new, so we went ahead and spawned a brand new object at the location, at the location of our empty game object. We're never changing this guy's location. We just said, okay, you are now created right here. Then, since this happens really, really quickly, before we actually saw him falling out of the sky, we changed that new object, dot transform position. We changed his position to be a little bit off from where it was originally by applying the nudge to it relative to the original guy. Actually, we're already doing the nudge up here. So actually, currently, we're double nudging. But we're still getting So really this guy, if we really wanted this to work the way we seem to be doing it, we want to so we actually don't even need the original position. We just need 3 nudge values, build a new vector3 with those nudge values, return the nudge vector. The output's not going to be visibly all that different. We're just nudging once instead of twice. So I'll just return the amount we want to nudge. Then here is when I add the nudge to the vector. So my new object pops into existence. Then somebody goes and shoves them. Then he was already starting to fall, but this happened really, really quickly. So he gets nudged a little bit, and now it's probably going to look pretty similar, but we're nudging him half as much now. And then I'll come to you. Okay. And some of them are bumping into each other, which is fine. It's not the end of the world. All right, go ahead.
Correct me if I'm wrong, but what you did in the very, very beginning was correct. Like, there's no right or wrong way to do it, but like what you were trying to do is you were trying to figure out how can I like incorporate this into the game object somehow, some way to make it do exactly what you already had it intended to do. But in simpler terms, we already had a vector3, and we already had our nudge vector, and we had our current box. We basically added our shift. But for me, what I was trying to explain was that instead of saying this dot game object dot position dot whatever, because that's basically instantiating from the enemy that we're dropping down, just do the generate drop position, because that's always going to stay where it is.
Well, the generate drop position, all that guy does is produce a vector3.
Which is the location.
But we get to choose what we want to do with that vector3. So that guy is just creating a vector3 with a little bit of a random X, Y, and Z. So that's all he is. So forget about how we intend to use it. That function, all he does is, if we think about him like a toaster, we say, hey, give me a new vector3 that's just a little bit off of center. That's all it is. So it's tiny little values. When it came out of there, we created our new game object not using that value. We just said, hey, I want to create a drop object for my prefab, and I want to put it right here at my empty game object, the thing that we started with, the thing we're never changing. So it starts dropping, it's in existence, but then we called our function right here, which just gives us a vector3. And we can think of that vector3, the way we intend to use it is to add just a little bit of a nudge to it actually, we're really not physically nudging it. What we're doing is we're just saying, your position is now a little bit different than it used to be. Go. We're not shoving it there, we're just making it there. But ultimately it gets there. But the shove part is important because if we shoved it, then the physics engine would take over and it would continue to be shoved. Where now we're just saying, you were here, now you're here. And now anything that happens to you from that point forward is based on collisions, blah, 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 that kind of stuff. All right. Now, obviously, we can get pretty out of control here. So I can do something like private int multiplier. How do you spell multiplier? That one? We'll start it off as a 1. We'll say for int I is equal to 0. I is less than this dot multiplier. I plus plus. We'll do all this stuff. But then after we do this stuff, we'll say this dot multiplier times equals 2. So the first time we'll drop 1 thing, 2 things, 4 things, 8 things. And now I'm out of fingers. so, so, so the first time through, after the first quarter of a second, we'll go through our loop. Multiplier is only a 1. It instantiates one thing, nudges it. Then we multiply to update our multiplier to be 2 the next time around, reset the timer. So now it's going to start raining stuff substantially more aggressively. Now each of these nudges are their own thing. Because we are calling our function multiple times, but also consider that these guys are going to be pretty close to each other. So they're going to be bumping into each other up where they're being instantiated as well. We could do something about that by maybe having them instantiated at different heights and then letting them fall as they fall, but at least they're in their own little layer where they're at, so they're not bumping into each other. But this is an imprecise visual thing anyways. All right. You can do it. Zoom crashes, everything's down.
My like charging cord hurt my finger a little bit.
Oh, really?
So hot. Yeah. I need a new computer in, but
Hmm.
yeah, I'm not pushing my computer that hard.
I can't even get this guy to stop. We'll have to try this again on my computer that comes Friday. This guy's a piece of crap now. I'm gonna use him as a bath mat. This one?
Yeah, what is that?
This is M4 Max with 128 gigs of RAM.
Yeah, blue trash.
Well, there's an M5 Max out now.
Hey, I'll take
That
it.
didn't survive.
Yeah, I'll take your extra computer.
He just said it was trash. You don't want it.
No, I do want it. I like trash.
That's not how it works.
I'll take your hand-me-down.
Take your. That's not how it works. Look, Dr.
If you get
Dr.
new
Lemon, who asked you first for a
Vision
computer?
Pros, I'll take the old ones too.
Dr. Lemon, who asked you first for a computer?
Brandon.
Not for a computer, but like if you had an older one that you want to use.
Oh, well, I mean, well, probably not you. People ask me for computers all the time. Out of this group, maybe you, but this one's going to Professor Kellogg. He gets my hand-me-down. Well, you can go ask him for it. He's replacing, I don't know what he has, probably an M1. He has an M1 MacBook Air, maybe.
I installed Linux.
Mac OS is already running on top of OpenBSD Unix.
Yeah.
It's the same thing. You could do. I install Brew. I install all the stuff you do from the command line. It's the same crap. Just works. There's third-party applications that are written for it. Where all the Linux third-party applications are written by other, Cody type people, and a lot of times they're thinking about what's best for them, not what's best for you. So what does that ultimately tell you? Write your own tools and don't worry about third-party people stuff. See, we just saw Unity crash. I bet you Godot would have done the same thing. We should write our own.
It never crashed on me.
It's never crashed on you because you probably haven't pushed it.
You just don't understand.
Leave me alone. Yeah,
You've just been taken captive by the system.
All right. The government spies. All right, so something I'm gonna do here. So I want to go to our prefab. Well, okay, so pretty clearly, and it's possible we might not be able to recover so much from this particular situation. I mean, I'm putting a lot of these things out there. We're seeing the power of 2. So maybe let's just make a tiny little modification. Why don't we just say multiplier plus equals 2. So 1 becomes 3, 3 becomes 5. Yeah. Huh? You just want to do 1? It's kind of cowardice. Is that the type of thing you do with Godot? No wonder it hasn't crashed on you. I mean, I'm not saying it's wrong. I'm just saying it's embarrassing.
Oh, look at that.
Ooh.
Broke again.
Oh,
Look at that.
What did you do? All right.
I
Well,
don't have Godot. Godot would be fine. Spawning same place every time.
quarter of a second. Here's my guy's position. Here's his updated position. It sort of is actually.
Oh, I'd be in.
I'm not really disagreeing with you. Oh wait, hold on. Let's look at our drop point there.
Just push to Godot.
Yeah, our drop point's not changing.
But it,
It's a random position padding.
Well, but we're seeing them spawn in those places, although that is based on our nudge. So he's wondering if we take our new object and we update his transform by generate drop position. This new object is brand new each time through here. So this guy is a fresh game object located at the location of this guy's transform. We just saw that that location is not changing. It is updating that new object's position by our drop position. So that guy would be changing. Fine. Let me change this back to just 1 second. I want to see if this is those guys literally shoving each other out of the way, but it really seemed like they were yeah, see it's starting. Ooh. That was violent. Almost like fireworks. Why are their positions changing? Oh, hold on. We are updating it on X, Y, and Z, which means that if we drop them down and it's getting enough of those low ones, it might be spawning right above the ground. Because we are updating X, Y, and Z instead of just, let me just shift and just change X in here. See if that does anything different. Now I kind of want to see this in Godot because this seems to be especially crappy.
no, it's working, it's just the way that you're telling you, it's something, it's the way that you're instantiating.
Well, I'm sure you're correct because clearly something weird's going on here, and I've done it on purpose as a lesson-based.
Yeah, no make us fun, Bob. But after to
Wait,
adding the position,
can I
just set the
propose
position
something?
out.
Sure.
So like, can I see your code? It's kind of. So remove the game object, the object that, yeah, both of those ones actually.
Okay, well, this is where I'm instantiating stuff.
No, but I'm gonna show you.
Okay, let's leave them there for now. I'll just write it below. What do you want me to say?
So. And you do this dot drop.
Well,
And then you dot, or excuse me, comma,
well, am I doing the object? I'm dropping the object, right? This dot drop object. Okay.
and then comma, generate drop position. Well, no, not this dot. Well,
This dot generate drop position, same thing.
And then quarter neon identity.
Quaternion identity.
Quarter neon.
All that's doing is changing the rotation.
Well, this is, what is?
Okay, well, let's try it. I don't want to. Who am I to knock it? If oh, thank you. Well, it'll compile. Let's do extra stuff.
Well, yeah, But also make sure that you're returning the current position plus the nudge vector. Because if you're only returning the nudge vector, it won't.
They go back.
Yeah, see, it's not working. They're still doing it's still doing something weird. Well, she said she wanted me to actually put in the nudge vector here. So I nudged X, Y, and Z. Then I'm returning the vector3. Oh. Actually, would have, those should give you the same value. I mean, plus is more correct, but they should both give you the same value because plus equals would have boiled down to this value with this value added to it. But we'll try it.
What, me?
Or is Unity actually crappy and you were right?
I mean, it probably is.
Yeah, but it's still spawning very low, isn't it?
Yeah.
Although that might be the nudge on the Y, like I was saying.
We're just doing that so you can see what it's doing.
Are you still nudging on all three?
I am.
Which means it'll randomly slightly change the Y from position to position, right?
Right, yeah. So that could be why it's becoming lower, or maybe I've lowered the thing down. All right, well, so in any case, and I'll put this assignment up. I think you messed with this on your tutorial, but we have something called tags. So the quick lesson here would be when things start getting slow, it's because we've instantiated too many things. Consider either pre-creating all of your game objects off the screen and then having them rain down. And once they get to something off screen, maybe you put a invisible floor, and when they impact that floor, move their position back up to the top. So you're always raining down the same stuff. And just as soon as it gets off the screen, so you're not adding stuff to your scene. All right. So that's a way you can get around. You find out how many game objects you can really instantiate before things get a problem. Maybe subtract 20% from that or something. Pre-instantiate. This is the same mentality that's used in network programming with thread pools, is what it would usually be called. All right, questions, comments, concerns, bribes. Front row of chapel, you're all invited. I'll see everybody on Tuesday.